Okay. In this, yeah, I would like to spend, let's say, a few minutes just to introduce CommOnEnergy project, and then I will let the floor to Maurizio to go into details of the technologies connected with the refrigeration. CommOnEnergy is a 4-year FP7 project started in September 2013, and the main aim of the project is to define technologies and methodologies and tools to support deep retrofitting of shopping centers. Shopping centers are a very peculiar kind of buildings with completely different end uses in terms of energy compared to other category of buildings such as residential or other kind of commercial such as office buildings or schools. The other building in the European building stock. The objective and targets of CommOnEnergy project were quite challenging, so a very huge reduction of energy demand, an action on the power peak, increase of renewable, and all these things while improving indoor environmental quality. We have 3 demo cases, one in Italy, one in Spain, and one in Norway, so different climate conditions and different contexts. And also the consortium is quite huge, 23 organizations coming from different contexts and different industry fields. And so EeB-CA is coming from, let's say, HVAC and refrigeration world. We also have other skilled partners and manufacturers in other technology fields, as well as we have academic partners and the owners of the 3 demo cases. And yeah. The first, let's say, phase of the project were to analyze the context of the shopping centers in Europe, and one of the main achievements is this definition of a framework including all the involved stakeholders, coming from the owners and managers of the shopping center, so who takes the decision also about energy retrofitting, but in general on management of shopping centers. Then tenants, so in a way guests of the overall shopping center organization with their needs and, let's say, their constraints. Then customers, the final users, so who sell goods who buy goods in the shopping center, and then the overall community, because shopping centers is also a quite, let's say, an impact kind of building in the urban context. So also local authorities as well as let's say the customers themselves and other workers are involved in a shopping center retrofitting. During the project, we are developing both technologies. We are almost concluded the development of technology phase. We are at the 3rd year of the project, and we are also developing support tools. So in a way that, we will allow the stakeholders mentioned before, and in particular designers and facility managers, to implement our technologies. First of all, in the design of the retrofitting, and then in the commissioning and operational phase after retrofitting. So we deal with the main technologies involved in contributing to the energy consumption in a shopping center. That is mainly ventilation, lighting, and refrigeration. And we develop tool for the design phase, this integrative modeling environment, and scenario tool to assess the economical figures in the early stage of the design process, and then the implementation through lean construction management, and also supporting the operational phase as well as through lean procedures, and then an evaluation of environmental and social impact. So let's say side effects of energy retrofitting, and then last but not least, this continuous commissioning platform enabling the energy manager and facility manager to check the actual performances during the operational phase of the shopping center, both from energy, comfort, and economical point of view. And with regard to demo cases, we follow the steps I reported in the slide, from concept to the validation, and these are a couple of pictures on the demo cases before and after the retrofitting. Other important, let's say, outcomes of the project are this IDP library, a repository of measures and solution sets, so packages of solutions to be used during the retrofitting phase, and guidelines for supporting the decision makers. Again, both facility manager or energy manager and designer. So the idea is to analyze the context, define kind of constraints and drivers for the renovation, and then fix or identify robust technologies to be implemented. Yeah, so the IDP library, as I said, is a repository. The idea is, at the moment, is in the private part of our website. The idea is to move the repository in the public part and consider this library as let's say, an open tool to be both used in a way to take best practices from the library, but also to fill in with new possible retrofitting action coming from other, let's say, cases outside the project. So the idea is to be a repository from which to take solutions, but also a repository to be furthermore populated with new possible retrofitting solutions. This is the path, the route towards the definition of retrofitting potential, so starting from the building and context features, and then analyzing possible shopping center archetypes. We already let's say, defined it in the project, and considering the specific building and the similarities with specific shopping center archetypes, it is possible to define a potential retrofitting. Guidance, as I said, coming from the design to the description of the different technologies as a, let's say, and the main target users are designers, facility managers, and investors. That's all as an introduction, maybe a little bit longer than foreseen. Sorry for that, in particular to Maurizio. And then I would like to let the floor to Maurizio, just to go into details of the use of natural refrigerant in the case of shopping centers. So Maurizio, please.
Okay, thank you, Roberto. Just a check. I guess I had 15-20 minutes of speech, correct? Production that is good, and explain how the methodology of the whole CommOnEnergy project. And now I concentrate on some technical and technological development that in this project, CommOnEnergy, that was an integration project, so it's not development of base technology, but development of integration of many little piece of existing components and system and technologies that fixed up together to obtain given advantages in a plant installation. Among a number of development of this kind, I want to highlight you these three concepts that, according to us, are good for deep retrofitting of shopping mall. First one is CO2 in transcritical pack. Then I will talk to you about a self-contained water loop and the use of R718, that is the technical name of a refrigerant, also commonly known as water, used for a sealer concept. Okay, first of all, maybe many of you knows that refrigeration systems has a penalty that is due to the influence of the climatic condition that arises by the installation site where the refrigeration plant is placed. In this map is shown how we categorize the Europe, so from the south region, that is a Mediterranean area of South Italy, Spain and Greece, to the central Europe in green, and up to the northern space. Particularly natural refrigerant solution based on CO2 are really suffering of this fact. The first ways that we can improve refrigeration system is, and this is an old technique, is the use of subcooling. In hot peak ambient temperature, CO2 suffer in of high discharge pressure, high discharge temperature, that could lead to even risk of oil burning, and then at the end energy efficiency penalty. So why not use subcooling, an old technique that need to be reinvented or reassessed for the use with transcritical CO2 plant, and to have a technology to subcool the CO2 plant. Anne, I lost the connection. Hello?
Yeah?
Ways, sorry, switch back one slide. Okay, I was here, okay. Subcooling means to subtract some heat from this added heat exchanger in this absolutely simplified view of the schematics. And a number of ways exist to subcool a unit. As an example, with a dedicated condensing unit interface to an air conditioning system, or using groundwater water sources to keep the CO2 cooled. Among the development, and now I come to the methods we used in CommOnEnergy, we were forced to model and to deeply analyze the components used in the refrigeration plant, and go through a number of simulations up to the control rule used in the system to verify how much it was the limits toward which the system could work against a number of hypotheses that at first asked to us to collect some information from existing plant, from store, and here you see in the table as an example the scenario with which we compared the result of the proposed unit, and classified for an average high and low temperature, and with a different subcooling method against them, with a given number of peak power that was used for dimensioning the system. I guess we have an issue on the presentation because there is a figure that is not there. So, it is the running energy against the temperature, and I'm sorry you cannot see that in the diagram is shown that the system with subcooling has the advantages to decrease the dry cooler pressure, and decreasing this, from this we gain the energy saving. I'm really sorry about that. I hope that we can load after a release of presentation with this graph added. Also, a number of saving has been calculated according to the kind of subcooling added. You can see here the estimation made by calculation of the energy that can be saved with this kind of equipment. Then for his end that at least is fully visible, so no problem on the final result, that lead to us to calculate the yearly simulated saving with different climate conditions, defined as an example, read the central one. In mid-climate we have an average of 18 degrees external temperature of air, and for less than 30% of the time we have temperature before or less than 13 degrees, and for another 30% we have a temperature that is higher than 23, so really a mild climate condition. And this is, we can get just 5% increase of energy saving. That is not at all zero, relevant enough to think to an installation. But of course, as I explained at the beginning, we concentrate the effort to the hottest region of Europe. The saving is much higher, and here is more convenient to think to this kind of systems. But there is also another way to say the same issues. Subcooling is a way to subtract heat. But if we can find a way to use this heat and then adding heat recovery, the gain, particularly the financial gain, that not the thermodynamic one, becomes even higher. Not the time to go even deeper in detail that are published on some paper or conference proceeding, but then we realized in a demo installation these concepts, and against transcritical CO2 packs, we installed also a recovery module, data cassette for adding air conditioning, and overall heater. And this overall heater is really an example of how the integration of this kind of solution can give a huge benefit in terms of efficiency of the system, a reduced number of equipment, and an overall gain on the plant that is very relevant, particularly on the high number of stores that not always are the biggest one in Europe. So, according to us, subcooling technology is very good because the system remains really similar to a standard transcritical. That is a well-known solution. It is a system solution that because they can take into account many different options to be added. Is really easy to adopt to people that are already practicing with the CO2 transcritical plant and solve a technical issue of transcritical system that is discharge pressure and temperature. So our understanding is a very good replication potential with a great benefit for an installation. I move now to a different concept, that is what we named self-contained CO2 water loop. It is again concentrated with a natural refrigerant, and it is a totally different way to promote a natural refrigerant plant with a good energy efficiency. First of all, let me explain quickly what is a self-contained water loop. In a display cabinet, you have to imagine to have a standard refrigeration unit like the one you could have, a little bit different from the one you have in a domestic refrigerator. A very relevant difference is that the heat rises from this refrigeration unit is then pumped in a heat exchanger that is connected to a water loop, and this water is then cooled by many different ways. One very simple is just a simple dry cooler placed outside the shopping mall. Also, this kind of installation is really ready to be connected to heat recovery, because this heat is connected to water, is the easiest interface we can have for recovery heating from the refrigeration plant. Over this, we analyzed required to us some tests and development. Here you see a diagram of how much is stable the temperature of the system against the variation of indoor temperature. So the system is running with an inverter and a brushless compressor, and the time constant of the display cabinet was much longer than the refrigeration CO2 loops, or in different words, it means that the CO2 machine was power enough to recover any transient before that the cabinet started to move its internal temperature. Is placed in a paper that is circulated, so interested people can have this paper sent by email. And here we showed that we calculated the capacity, and we were forced during the installation to make a deep verification that the calculation was really true and not affected by error due to the instrumentation. So we invented or tried a way to prove the calculation about the capacity and the coefficient of performance, adding using a differential analysis thanks to an added 47 watt load in the refrigeration while it was running in a certain time. In the diagram, it would be shown that the capacity was in two situations was exactly differentiated by 47 or very near to 47 watt, so validating their processes. So thanks to this activity and thanks to the analysis not really very visible here, we were able to mix together data from the field and data from the test to arrive to an estimation of the seasonal COP of the system that at the end for a system and in the given condition that is written here, so basically temperature difference to the dry cooler of 7 Kelvin, we found that an overall year COP of the unit was around 3.28. That is all year round COP referred to a minimum water temperature of 19 degrees and installation in Düsseldorf, Germany. Here is the prototype built, is CO2. You see here on the top of the CO2 unit, and those pipes that hardly can be seen here are the water pipe connection. And the system was a double glass inch door with M1 performance, so is a top performing display cabinet in the range of hectare. What is distinguishing from competing technology, so what is relevant to note of this technology, what is new, is that the unit is a sealed unit, so only connection to power grid and water is needed, meant for easy installation in field. Each unit, and this is an advantage, is optimized during the construction phase in factory, and it is designed for its smoking mode specific need that rises from the design of the cabinet. The included charge is very reduced. This is not very relevant with CO2, but speculating possible new future refrigerant reduction of charge would lead also to reduction of volume and cost of the system. The plant becomes very simple in its simplest execution, and we gain a very good easiness of integration with HVAC systems thanks to the heat reclaim through the water surfaces. Clear and to explain to potential users that there are also these advantages that are, in our opinion, overpaid by the advantages, but for sure we have an additional interface. So from a thermodynamic point of view, there is an increase of temperature differences, and also to maximize the benefit frequently in installation, an additional heat pump is required. But these two are very little disadvantages compared to the advantages told in the first part of this slide. Now I move to we added to the I moved to the water chiller. That is water not only because cool the water, but because in this concept proposal it uses water, so R718, as a refrigerant. So the same way in your domestic refrigerator you have isobutane or propane or CO2 in a big installation. And the reason why, of course, the reason why we started to look at this is because, of course, water, even more than CO2, has a great benefit in terms of environmental condition. Maybe it's obvious, but I want to stress the point that even CO2 is very natural use, but again is an industrial gas. Using water, it's really even if very purified grade for refrigeration and compression processes is totally natural and widely available fluid. So very eager from this point of view. The very good thing is that recently this fluid has been proposed also by others, so it's a technology that could be ready or can be used in some times. And added to this, it has an extremely low pressure in plant. Running evaporating pressure is around 20 millibar. So it would mean, if you see the scenario, that you could think to pipe of refrigerant that can made be of plastic, very weak, apart that they need to resist to the mechanical stress when you place them in a plant. Okay. Sorry again, I'm missing diagrams, but I have to tell you what was the content. Yeah, in this we tried an application scenario, and water as a refrigerant can be very good, even better than ammonia and propane, when small temperature differences is considered. So the very good application thought for our application is why not to add this kind of machine to cool the water of a CO2 system. Okay, again I have to switch back, sorry, to this slide because the other diagram is not present. So if we would be able to add in place of this equipment this water loop based also on a compressor, we can keep this water down to 18 degrees, even when the ambient is very high, up to 45 degrees, and gain efficiency in the refrigeration side. And these small temperature differences between 1820 to 45 can be the good work and the good job of a water chiller. Calculated COP is very high, and in this scenario, taking into account the summer season, that is the hottest period in which a refrigeration plant typically can have additional load to the air conditioning system, so it is in this period we have to pay attention to the efficiency. You can see that against the base case and according a number of different scenarios, we have a total energy consumption that is reduced, and it is further reduced. The biggest is the R710 chiller sized. Of course, this would mean that the capital investment cost would be higher. So probably a good option is to stay behind in this area. Really sorry about missing diagram, but I almost finished. Of course, I'm here to have some question, and I hope we'll be able to load a corrected presentation PowerPoint for the ones that are interested. Thank you.
Thank you, Roberto and Maurizio, for this very detailed presentation. So we will now go on with the question and answer time. So Regis from CSTB has a question. So Regis, you have the floor.
Yes, hello. Thank you very much for the very interesting presentation. I have quite a general question. I was really impressed by the target you presented at the beginning in terms of energy savings. I think you mentioned 75%. So my basic question is what about the business model and the return on investment you can expect for a shopping center who is interested to invest in those innovations and those technologies that you just presented? I imagine the return on investment is rather short if we can expect 75% of energy savings.
Yeah, thank you for the question. Yeah, for sure the target was very challenging. What we found at the moment, I mean, we are working on 11 real buildings in Europe. 3 are the demo cases, and other 8 are what we call the reference buildings. For those buildings, we performed simulations using one of the tools I mentioned before, this integrative modeling environment. And we are in close contact with the building owner or building manager. And what we found out is that, I mean, we can be very close to this 75%, and let's say, talking about payback period, we can stick below the threshold of 10 years. That is quite a long period for a shopping center. For some technologies, for example, lighting using LED, the payback period is very short, few years. What is common to all the solutions we develop is the very high investment. So we are talking about, let's say, millions to refurbish, I don't know, a shopping center with a size from, let's say, around 10,000 square meter of leasable area. And this is, again, we discussed it with stakeholders, because we organized a couple of workshops with stakeholders just to present our results and having their feedbacks as, let's say, people working daily with these figures, with these numbers. And they say that, I mean, a few millions as an investment to be put on the table in 1 year is, let's say, too much, and is, let's say, nothing that they can really do. But what they usually do is to have a multi-annual plan for retrofitting, and also considering that a shopping center, let's say, as a sort of continuous retrofitting process. So if we, let's say, consider this investment not as a single and unique investment, but an investment part of the retrofitting plan, and let's say in a way implemented and executed in different years, let's say 5 years or something like that, I mean, this could be also feasible for the economical point of view, also considering not only, let's say, the energy saving and the, let's say, payback time, but also the improvement of the indoor environmental quality. And we also, in our, let's say, investigations, we also found out that, I mean, it seems that there are also a correlation between indoor environmental quality and amount of, let's say, the selling amount of the shopping center. So in a way, the shopping center becomes more attractive if the shopping center has a better architecture or a better indoor environmental quality. So I would say that, at least from the theoretical point of view, but also having these feedbacks by stakeholders, 75 is achievable with, let's say, also a viable business model to implement our retrofitting packages.
Roberto, if you can add some few words about
please.
this. Of course, 75% comes from a number of technology and development that all together contribute to the overall So from facade to technology used for refrigeration up to many other things, lighting and so on. So considering all of them, of course, you have this kind of overall impact. Of course, in the project is very wide and cover many different aspects in retrofitting. I want to add a few words about what we presented to clarify about the point about refrigeration. If you want, they were presented in order of reduced capital cost and so fastness of payback time. So subcooling system today now are developed and sold, and according to our experience, we are already on the market side. So we have already customers that are choosing them. So it is proved, let me say, by the market that the return of investment is considered good. Of course, there is a number of options very wide. So according to the customer, they can choose from very simple solution for a very fast financial recovery, or a complex solution that adds some capital cost, but with a net profit at the end of 10 years, because in our experience, it's not only the payback time that is used. Sometimes customer looks also, they open shopping mall for making investments, and so they also look to the return on investment. That is also a very good parameter to analyze the system. Water loop system is a little bit more complex today, but even this kind of system with a standard refrigerant, not CO2, is today on the market. And also this kind of solution is chosen what is the right condition to do that. Instead, the water sealer today is still a concept, so not yet only verified by simulation, and we don't have today a clear view on financial return, even if our thought is optimistic on this point of view. So in summary, on this kind of technology, return on investment is exactly in the area that normally owner of the building is willing to use. Okay.
Okay. Thank you, Roberto. Is there any other comment or question? No, I don't see any.
I've got maybe one extra question, but it's so what you presented is really advanced technological solutions for retrofitting the shopping centers. But my question was, did you look at the more traditional retrofitting option, for instance, simply improving the insulation? Because I was thinking that, at least in France, I have the feeling that shopping centers are really poor in terms of basic insulation and things like this. So I just wondered if you had a look in the context of this CommOnEnergy project at the ways shopping centers are insulated and well designed, I would say, before thinking of more advanced optimization technologies.
Roberto, you, me?
Yeah. Yeah, as you want. I mean, I can start and then you can, or the other way around. Please.
Okay, try to revert the order. I start. I think, okay, the general, so the first goal of CommOnEnergy was the deep retrofitting. So, of course, we considered a very strong impact and in the renovation of the system. But many of the technology developed was thought with paying attention to the replication potential, so, and specifically the one of the refrigeration was also looked at in order to investigate the retrofitting of shops that only goes through what Roberto explained as the continuous retrofitting process, looking also to small size stores. I don't know, Roberto, if you want to add more on this.
Yeah, maybe I would like to underline what you, Maurizio, said, that we develop systemic packages. That means in the project we call it these solution sets, and we included in the solution sets both technologies we develop within CommOnEnergy project and let's say, as you call it, Regis, traditional kind of energy efficiency measures. But I would like also to underline what I said at the beginning, that, I mean, shopping centers are very peculiar kind of buildings, and if you have a look to the, let's say, energy consumption end uses, energy consumption cake, I mean, the part of heating is very, very small in almost all, let's say, European context. We have a case in Norway. Of course, there we started from the point that the building is already well insulated, considering the climate condition in Norway. And starting from that, the most profitable intervention there was to act on the lighting for two reasons. One, for the electricity, let's say, consumption for the lighting itself, and the other one is the consumption for cooling. They have a very old lighting system and a very old architecture, not using, almost not using day lighting. So what is happening there is that I mean, they have all these old lighting systems switched on all the day. And so they also have a cooling load, even if we are in Norway during spring. That is, let's say, something, let's say, against any energy efficiency approach. So what we are installing there, what we are implementing there is, let's say, both day lighting strategy. We were, let's say, making holes in the roof just to install light tube, a quite peculiar kind of light tube, including also artificial light within the tube, just to ensure let's say, the same level of lighting quality during all the day and during all the year. And on the other side, we already installed a quite high efficiency lighting system, LED based. Using insulation in this kind of building sometimes is not profitable. I mean, the return of investment, as let's say explained by Maurizio before, for the insulation is not so, let's say, good. And so we considered also this kind of traditional retrofitting measures within our solution set. But the most meaningful effect is the systemic effect, combining natural ventilation, lighting, natural lighting strategies, refrigeration also coupled with, let's say, HVAC system, so with a lot of recovery of waste data. All these, let's say, measures together can, let's say, allow to achieve the targets fixed by the Commission. Also, in a, let's say, in a cost-optimal way, so within a profitable business model for the shopping center developer as well as for the shopping center manager.
All right.
Thank you.
Thank you. No further question or comment? No.
Everyone, this is Sandrine Doralto. Okay, just as a conclusion, I would like to draw your attention on our final project activities. Well, the first one will be the ECTP conference, which will take place on the 17th and 18th of November this year in Brussels. So, well, the ECTP conference is aiming to present and discuss the current and new findings in the built environment field. So, of course, if you are interested in participating in this conference, this is still open. You can still register yourself. As information, we have a booth there, and there will be a whole of booths and poster which will present example of innovation expected from EU projects. So this might be also interesting for you. Yeah, and so there are some other information regarding how to participate and how to book a booth if you are interested in. Then during this ECTP conference, we will organize matchmaking events, which will take place on the Friday afternoon from 1:30 to 4 p.m. In the afternoon. And so these matchmaking events is also to give you the opportunity to meet stakeholders and to organize bilateral meetings. So the idea is to also discuss maybe new research or business opportunities, or even to discuss maybe new project ideas for the new course. And so if you would like to attend to these matchmaking events, this is the registration is for free. And you can have more information and also have an access to the online profile catalog if you go directly on the event website, which is here. I'm showing you the link. And so if you would like also to have this bilateral meeting, you can upload a profile or technology or service offers. And so the participant can also have a look at your profile and maybe contact you for bilateral meetings. So this is for free. This event is for free. Then we have the coaching service. So we are at the moment offering innovation assessment. And so, well, this is a very simple process. This is also offered free of charge for all EEB PPP projects partners. So the first step will be to, well, first to contact us, and then you will get a questionnaire, which will be filled by you. Then you send this questionnaire back to us, we make an analysis, we write a report, and we also propose you some recommendation on how to improve the identified weaknesses. So this will be to assess the innovation and the competitiveness potential. So if you are interested in, just do not hesitate to contact us, and this is, again, free of charge, so do not hesitate. And then the last point, this will be our LinkedIn group. This is actually a part of the ECTP LinkedIn group. So if you are not already a member, I suggest you, to become a member. Again, this is free of charge. And this is also a very good tool because it will provide you the opportunity to publish, well, to promote your project's results and activities to a very large audience of professionals. So for dissemination of the results, this is really a very good tool, I think. And then that's it. So,
Okay. Thank you, Sandrine.
Bye-bye.
Bye-bye.
Okay. Thank you. Bye.
Thank you, everyone, for your participation. If you wish to attend the 4 other webinars organized next week, just come back to me and I will send you the details if you were not invited already. Yes, and so I will share with you the presentations of today. Thank you to everyone and have a good day.